Thank you very much for the perfect introduction. Besides the motorbike, I'm actually living in the airplane for the past couple of days. So just, be patient if I suddenly fade it out because I'm a little bit jet lagged and traveling too much. But I want to talk to you about exciting and amazing world of fintech and financial applications because these applications are specific. Just to start this presentation, can I ask if somebody from the audience already worked on some financial application? Could you just raise your hand? All right, so it's about 50-50. That's good news. I can see some of our customers, partners, competitors, everybody. So that's amazing. So a little bit about Wultra. We essentially provide authentication system to banks and fintech. We have been on the market for quite some time, since 2014, but quite frankly, everything accelerated about 2 years ago after we got our first investment by JNT Ventures. Since then, we are essentially doubling in size, and currently we are present in 15 countries and growing. So now what we typically do is that we work with banks. That's one category. But we also work with fintech companies with slightly different types of animals. And before I dive into the presentation itself, I want to make a little confession first. So when I was about 10 years younger, I used to be a hopeful mobile application developer. As you can see, I was an iOS developer. This was just to mock Android developers in our team. I mean, I could occasionally do Android development if I really had to, but I really don't know much about Android. But over the time, I was essentially failing to the top, and I became a CEO and founder. So I decided to position myself during this mdevcamp as the most business-oriented presentation of everybody. So if you are looking into deep dive into some specific pointer behavior in C++ code in our cryptography, you will be very disappointed. If you are looking for an overview and for what you shouldn't forget about, that's probably the right talk for you. And now, so why am I even here then? If I am not really a developer anymore, I basically failed as a developer. Everybody in my team is smarter than I am, I can say quite confidently. First of all, fintech is a really amazing vertical. From the perspective of a Czech company or a European company, it may not look like it. But if you look at the global perspective, if you zoom out on the planet, there is still lack of access to finances, lack of financial inclusion, lack of availability of fair products that do not try to rip you off. And so there is plenty of space and plenty of opportunities to build a fintech app. And the second reason why I'm here is that you are all developers and I want to protect my sanity. So I'm convincing one after one developer that building fintech application requires special care. Because what we see quite often is that financial apps are hard. People who are building banking know it very well. People who actually build fintech applications could be a bit, too enthusiastic about building the new thing. And very often, when we have call with a new prospective fintech customer, it basically looks like this. 3 guys in a t-shirt with an idea. Well, it doesn't really look something like this. It looks more like this. One of those guys is an Android developer. I will not tell you which one, of course. And typically what we hear from these guys is, we are launching in 3 months. So, okay, that's optimistic. You can do it. You can build an application like a banking app from the user experience perspective in 3 months. That's kind of doable. But then we check on them after 3 months. We are asking, okay, so how about the authentication that you probably should have now when you are launching, right? And typically we learn that banking is complicated. That's really actually one of the sentences from one of the emails. I copy-pasted it. Turns out banking is complicated. Amazing finding. So what happens after 6 months, 9 months? People become desperate and they learn that there are 3 main specifics that essentially kill your fintech project. The first one is user experience. And surprisingly, user experience is not really about making things as fast as possible, because doing things fast can sometimes alienate people. So you really need to do your research on how to do, for example, new account opening. In fintech, you have essentially no chance in low volumes. There are some specific products, but you need to reach mass market. And as a result, it requires really doing your research. So this is a bit demotivating for mobile enthusiasts who really like animations and cool stuff in UI and new technologies, because this is not what most of your customers will eventually care about. The second reason is security, which is actually our primary domain. And Money is actually something that cybercriminals really, really want. It is the most liked target of cybercriminals. And so as soon as you reach 50,000 customers, you will eventually become target of some fraudsters. What we can see in the Czech Republic is that there are different categories in fraud. There is, for example, this small fraud where somebody convinces you to make an e-commerce purchase, 3,000 euro damage per incident. There is wishing. Somebody convinces you for a really good investment, which is attack with 50% success rate. Every second victim falls for it because it's really convincing. And the damage is approximately 10,000 euro per victim. So it's a lot of money per victim. And we have some record attacks essentially in the sizes of hundreds of thousands of euros per victim. So it can really become quite expensive not to invest in security upfront. And I will remind you that these attacks actually happen despite all these investments in security. So if you underestimate it, you're done. And finally, I think that there is a very specific lifestyle if you want to get to prison. That's really it's a CV item, quite unique actually. Especially in some exotic geography, but. Regulation tends to tell you a lot about how you should build your application. They tell you how you can create new accounts. They tell you how you can authenticate them. They tell you how you can secure your mobile application. That's something that you need to follow. If you don't do it, you fail your obligations, and the least that can happen is that you will be blacklisted and essentially you will lose your license. The worst thing that will happen is that you will go full McAfee and you will run in a forest, with machine guns, and that's a lifestyle. Maybe, not me. So, in your fintech lifestyle, if you essentially do not handle these three topics, after 12 months or so, you will have to go back to your corporate boring job. I kind of uncovered which one is the Android developer on this one, but that's what will happen. But it doesn't have to end like this. And I want to show you a great example of our customer, Honest Bank, which is an amazing Indonesian fintech. They built basically Revolut for Indonesia, and the sentence, "Turns out banking is hard," actually comes from Peter Panas, who was my boss at Avast, who built this fintech. And despite initial lack of, let's say, realism in approaching the project, they managed to succeed tremendously. They have hundreds of thousands of customers in Indonesia, growing hundreds of thousands every month. Amazing project just by starting doing things properly and paying attention to it. So what comes next is my checklist of what not to forget about when doing fintech application, because these categories are quite well defined already. I think that you can now mainly differentiate your fintech with the service itself, with the product, with the financial product, not so much with the application, because regulation just gives you this narrow corridor that you can follow. And if you look at a typical mobile app just from the cybersecurity perspective and compliance perspective, first thing that you need to pay attention to is digital onboarding. Essentially, two processes: know your customer. You need to know who is using your application very well. And AML, you need to know it isn't a terrorist or somebody who is laundering money through chain of companies in tax paradises. The problem is that this is really difficult to do globally because it's really depending on local legislation. But generally, it is about document recognition, it is about facial recognition, it is about video calls with your customers. The second item is strong customer authentication. You cannot log in users just with username and password or keep them logged in. In European Union, we have something called PSD2. It's a payment service directive legislation that forces you to log out customer after 5 minutes of inactivity. You can have at most 5 attempts. There are some specifics on how to log customer in. And as a result, you typically should pay attention to this specific topic. Then if you are building application for Asia, for countries like Vietnam, but it will eventually come to Europe too, you need to have server-side biometrics, something that recognizes the person. So when you are using Face ID for authentication, that's not really biometrics, right? It is kind of a biometrics, but you don't know who the person is. It is somebody who uploaded face to the smartphone. So that's no longer possible in Vietnam, for example, if you are paying over certain amount of, over certain value of transaction. You really need to check the face against some biometric template on the backend. I'm saying face, it's typically face. We actually saw camera-based hand biometrics, which is super interesting tech. And even there are some research projects related to fingerprint scan using camera, which to me is quite strange. I don't think this works, but face is typically the way to go. Another one is in-app protection, because typically if you just build your application using common development tools, it is still vulnerable to attacks on compromised device. Currently, legislation worldwide is set against the bank, against the fintech. So what for example, PSD2 says is the following. If your customers modify their devices, and if they modify your application and it results in a compromise, bank must have some way to first try to prevent it or to mitigate consequences. So if some damage happens and the regulator asks the bank, what did you do? And the answer of bank is nothing, it's customer's fault. It doesn't work. That's basically not allowed. You have to have some measures in place to protect the customer, whether they want it or not, essentially, is the idea. Surprising for many. Now, secure networking is something which is quite common. I think the main issue that we currently found is issue with certificates, which are no longer issued for 2 years or 3 years. As a result, you need to rotate the certificates in your certificate pinning quite dynamically, and this is one task that you should pay attention to, because it is no longer possible to just pin the certificate, build it in. You would have to update the application and implement force update, which is not very convenient. This brings us back to the user experience. Another one is anti-fraud SDK. So just, it is getting complicated. So you need technologies for all of this to actually build a fintech app, right? And if you are building it in-house, you will eventually get stuck in, just building something that doesn't bring any value to the customers, quite frankly. But anti-fraud SDK is something you can get from companies like Threatmark or Revelok. You put it in your application and it essentially collects data about behavior, transactions, anything initiated in the mobile app. Then built-in anti-malware, again, legislation actually forces you to check for malware on mobile devices. This is currently only relevant on Android. And finally, something that you can do yourself is documentation, boring stuff that you typically skip. But if somebody asks you about how do you do these things, you should be able to promptly answer. So that's a bit of an overview. I don't think it's definitive. I think that I can go through many more important items, especially if we go outside of security to card payments, for example, and these topics. So if you look at fintech application, it is essentially a composite of SDKs and composite of technologies. And of course, I will not be talking about all of these items in detail. I selected these 3 because we understand them the best. Basically, that's the idea. So a bit of a discussion about mobile onboarding. Essentially, how do you get your customers? Typically, in mobile application, you have something like login with Google or login with Apple. That's not applicable to finance. You can't do it. You need to have a proper know your customer process, and typically you need to verify the customer. Most frequently, this is happening by capturing your personal ID and by going through facial biometrics to verify that the person on the document or person from the government database that you can collect from the document is actually the right person. That's something that can be done in 5 minutes, but of course, it is only possible if camera works, light is right, it is a bit of a fiddly process. I think that document capture is currently the main friction point in a funnel of a fintech app, because it just takes time and it requires good lighting and so on. And it is not allowed everywhere. For example, if you want to open a bank account in Germany and you want to do it remotely, you actually need to go to a video call with the employee of the bank, and you need to be showing the documents and you need to go through this personal verification. You cannot do it fully automatically at this moment. You can, but you need to have personal ID with chip card reader, which is probably worse than talking to someone over the Zoom call. Even though not for me, I'm still a bit shy person, so I don't like calling to anybody or talking in public. So one of the issue of this process is that it is quite costly. If you actually go for a solution that does everything right, you essentially pay something like €2 per verification, per full onboarding, which is still quite cheap because Czech Bank ID, I think, charges something like €4.50 for full verification. So it's a good price that you can get to. But now, not all solutions in this category are equal. Actually, if you look at this category of we will scan your document and we will do facial verification, it's a bit of a red ocean. A lot of companies doing the same thing. Of course, AI in the past years enabled easier building of facial recognition features and document recognition features. There is much better support on iOS and Android through machine learning features and document capture, which is built in. But that's actually not enough, because it's not only about extraction of data, it is also about how you validate the document, that it wasn't captured from the screen, from a scan, for example, that it was not modified by replacing the photo of the person by somebody else, and so on. Facial recognition is basically the same thing. It is quite easy to do face matching, recognize that two people are similar. But how do you prevent deepfakes? That becomes quite a big problem these days, especially if I look at what is currently possible. We still don't have interactive deepfakes, but it's just a matter of time before we have it. So you need to have anti-deepfake features, and features that prevent, for example, streaming data directly from camera to some relay device. And finally, this is about orchestration. You always need to connect to some source of truth. And what happens when you check all these boxes? You look at your completion rates, and you find out that you selected a solution that ticks all the boxes from compliance perspective, but it sucks from the UX, right? So that's the problem of the balancing these two things. Luckily, there are some movements in a good direction. One of them is European Digital ID Wallet. This will probably change onboarding, revolutionize the field, and significantly consolidate the red ocean that I mentioned. So typically this will work by governments providing the ID application that you can use to onboard customers. So you will start with your banking, then you will request personal data of the customer. Wallet will authenticate the application and pass trusted verification, trusted verifiable presentation of the credentials to your banking, and you can just let the user in immediately. Hopefully this will be as easy as that. If you want to read a little bit more about this on a technical level, I recommend looking at verifiable credentials and verifiable presentation. That's the technology standards that will probably be used in most cases. And I think that opening a bank account or starting a fintech in 3 to 5 years in European Union will significantly simplify. It will not be as complicated. You will not be building document capture over and over again when this is only needed in one application to establish trust on the device. And the best thing is that besides being fast, this will be done for free. So you'll be able to onboard customers much more cheaper. So zoom out again, new opportunity in fintech, building services that can quickly onboard customers. Of course, one day we will probably see Apple stepping in. They already do so in the US. You can already upload your driver's license. You can present some data just as you use Apple Pay or any features in the wallet, and you will be able to pass your document in something like 2 seconds, probably for free or maybe for a small fee, something. So this is the future in, I would say, T plus 3 to 5 years. And actually, if you look at the documentation of iOS related to documents, you can already read through it. It is already available, so you can get ready for this type of super simple ID wallet. All right. So this was onboarding. Let's jump into strong customer authentication, which is actually the last code that I coded in our company on mobile. So you will see my awesome API that I prepared. Essentially on mobile, what you are trying to achieve is to have a strong customer authentication, which is multi-factor, linked to your mobile device very strongly and linked to your application. So then you can use the identity everywhere, in a mobile application, of course, but in internet banking, e-commerce applications, third-party apps when you publish your API, and so on. And multi-factor authentication on mobile, surprisingly, can be done only with one device. That's maybe apparent to those people who raised hands in the beginning of the presentation, but not so much apparent to the rest of them, because one factor is a possession of the registered device, and second factor is PIN code or biometrics. So it doesn't require 2 separate channels, like password entered in a web interface and SMS delivered to mobile device. This is actually something called multi-mode authentication, when you are using multiple devices or channels to authenticate. And really, there are 2 main situations that you need to pay attention to. First one is, how do you connect this multi-factor authentication to your account after you download the application? And basically, what it requires is some first step. It can be entry of username, password, and hardware OTP. It can be digital onboarding flow. It can be anything that verifies the customer. And then you need to register the device, set up the PIN code, and set up biometrics, right? And so typically if you implement it in our code, you perform the initial verification, you obtain something we call activation code, and you can use the activation code to create something we call activation. And if the activation is created, you can use it in this call create activation, and you will return, receive result. So that's how you enroll the device. Under the hood, we will take care of networking, cryptography, secure storage, everything which is related to making this process secure. And in the second step, you just set up your PIN code, and you can specify to actually also enable biometrics. So again, we will take off the burden of this relatively complicated biometric authentication, especially on Android, where you can, again, not that I have anything against Android, as you probably know by now, but it is much more complicated to actually handle all those biometric states there. But we package it in the SDK so that you don't have to. So now the second process after you connect your device is something we call transaction signing. It is actually quite old term. You can use strong customer authentication interchangeably, but it is about ensuring that login and payments go from right user, right device, right application, and that you have strong, unique, one-time multi-factor proof. And what we recommend to implementations is focus on implementing this PIN keyboard as a separate component, because there is quite a lot of things happening. You need to have remaining attempts, you need to have PIN digits adding and removing, you need to have this delete button that changes to cancel if you are in 0 digits, you need to have a biometric trigger that you can trigger automatically when the PIN keyboard launches, but you can also keep it closed if you, for example, have use case that shouldn't immediately be triggered by biometrics. So that's quite a lot of effort. We do not do the user interface because we gave up. It's just everybody just wants logo a little bit higher. That's something that we already found out. So what we provide is essentially this transaction signing feature where you can specify authentication factors you want to use. You can specify data that should go into the signature, like what endpoint are you calling, which HTTP method, and what is the request body. Then you can create signature for the HTTP request, for example, for login and payment, set it to your HTTP client and post it to your URL, for example, to login. So again, we take care of triggering the biometric dialog, computing the proper cryptographic signature, preparing the ultimate header, and you can just use it. I am showing this code because everything is actually open source. You can visit our GitHub and you can get it. That's quite straightforward. Just have a look. And one interesting thing that is currently almost market standard in advanced authentication biometrics, advanced authentication solutions, is that everything is actually happening in shared C++ core. So, for example, as you are entering the PIN code, it is automatically inserted in encrypted part of memory, so that if you dump the memory, you never see the PIN code in plain text. If you just finish entering the PIN code, signature is actually computed inside of this secure context, so it never leaves this secure context unencrypted. No keys are actually left behind our code. And it's done very transparently. As a programmer, you don't need to really pay attention to it. So the final topic that I want to cover is runtime application self-protection, because having onboarding process or authentication process makes no sense unless your mobile device is secure. Because if you are on compromised device, which is, that's a bit of a philosophical issue, because whenever I talk about this, people think about, okay, but many people don't have compromised devices, right? If you assume that people don't have compromised devices, nothing makes sense, right? But if you assume that the device is compromised, you really need to have strong protection on such a device. If the device is rooted, you cannot have shitty root detection, because on rooted devices it is easy to disable. On non-rooted device, it doesn't really matter, right? Because why would you even care? So one of the issues that we were dealing with is, or rather than issue, it was a concern at the time, is that somebody will record our PIN code on the user interface layer, basically just tapping the buttons. That's something you can do, and replay it, which will result in a perfectly valid signature. Everybody could log in, right? That's functional. You can do it. We know you can do it because we actually made a very convincing prototype to some of our customers that you can do it. So that's quite cool. If you see it really works on Android through accessibility services, for example, that's awesome. And Of course, you need to pay attention to it. Your applications are fragile. They can be easily decompiled, they can be easily repackaged, they can be easily tampered with in runtime. Typically, if we find mobile malware on Google Play, it is a repackaged application, some legitimate application of, for example, PDF editor that was very successful, and it is published again under slightly different name with the same copy-paste description. So making sure that you cannot be repackaged can actually save you a lot of reputation, because if there is like a news article that fake application of your fintech is causing trouble, that will cost you some customer acquisition. And the most interesting thing is that when I was still active developer in 2014, it was quite difficult to do all those things. I mean, yes, we had Secrypt, we had some tools that enabled us to do decompiling, but currently you can just download stuff. It's super easy. If you are a script kiddie, you can go to APK support, take any application from Google Play through it. It's a web interface, super convenient. I do it for sales purposes still. If I want to learn what the application uses, then you can put it in JDEX, which is again easy to download. You can decompile it, see the source code. You can play with Frida, with objection, quite simple stuff, nothing surprising really. There are even generic scripts, for example, to disable SSL pinning, to disable root checks with Frida, so it is not difficult to bypass stupidly written root check currently. It's something that people can commonly do. And number of issues is actually growing. Luckily, OWASP mobile application security verification standard is doing a pretty good job to keep up with those issues. So if you just visit OWASP's specification of resilience, they give you a pretty good checklist on what to do, and they actually have like a testing manual where you can look at how you should be testing routing, what tools you should install, how to set them up. So this is great for security testers. It is great for fraudsters. The field is quite leveled for both of these parties. And you have different categories of problems caused by another application, categories of problems caused by lack of your application integrity and easy readability of your source code, issues caused by insufficient protection during runtime, your process and your memory is not really protected, issues caused by system features. I love Android's accessibility services. This is such a good selling tool for anything. You can just show how you can do anything with the application, basically capture the content, interact with the user interface. Awesome. And there are also other data leaks, like external screen sharing. That's actually quite popular. There is a lot of recommendation not to use charging points at the airports and so on, because you could be actually projecting your screen to somebody. And typically, what we recommend our customers is that the problem is no longer simple. You cannot really write your root detection by implementing method isRooted with 10 checks, 15 checks, 20 checks, because what the attacker does on rooted device is that they insert return false in the beginning of your method, right? So no matter how many checks you do in the code, it doesn't really matter. You need to have much more resilient features, and we typically start by hardening the application bundle by essentially putting tens of thousands of integrity check in the application. So every class in your application through our systems can be hardened, protected, and impossible to modify. It is also a good idea to extract sensitive constants like URLs, embedded keys, anything which is visible in your application as configuration value from the application, encrypt it with a heavily obfuscated key, and then put it back in the application in runtime when your application is fully loaded in a system which passes compliance checks in terms of, let's say, some security policy. The second layer that we pay attention to is something that we call upshielding. It's actually a category of application tools. It is something that protects your runtime. It disables running on emulators. It makes sure that no debugger can connect to your application, or that for example, process is renamed to be invisible for somebody who is just looking for your process name in the process name list. And if you implement these two layers, you are basically 80% done, which is the good news. But you can continue. You can provide some additional, let's say, business-related features, something like let's notify the user about some problematic state, or let's provide security advisor. Let's log some problematic information to our anti-fraud system. So these are let's say, 3 different layers: hardening, protecting the application bundle; upshielding, protecting the application process and memory; and another one in our product line, it's malwarelytics, which is about making the business features, the security features visible to the customer and acting based on them. So a little bit about the upshielding. I mentioned this is the important step. We actually work with our friends from Promon. It's a Norwegian company, so I'm essentially promoting somebody else's product. But the way this works is that you take your application, finished APK or ABB or IPA file, you prepare configuration with different settings, and you can run it via tool, for example, in your build pipeline, or even from Xcode or Android Studio if you want to. And it automatically creates modified application bundle for you. So it isn't difficult to do. These things are fully automated. You don't need to really implement anything. It is not a good idea to do it on every build because upshielding takes like 1 minute to complete. So it's not really, if you shift the button 5 pixels right, you don't want to go through upshielding step again. But for pen testing builds, pre-production builds, and production builds, that's a good idea to enable. And this is typically how we use it from the command line. So it's really like one command with the utility configuration, optional key store parameters, and your APK. My time is not my time, but presentation time. this would be very dire end of the presentation if my time was running out. But the presentation time is running out, and I would like to just recap the 3 main specifics that people typically underestimate. User experience, you really need to pay attention to it, but keep in mind that it's not about making things simple. It is about making things trustworthy and comprehensive. Security is the second one. You can lose a lot of money if you don't invest in security in your fintech app. And legal, basically politicians are talking what you should be doing, and you have to do it, otherwise you can end up McAfee style. So you can visit our developer portal. This is something that I recommend to do. It's quite straightforward, developers.vultra.com, where you can see everything that we built. It is something that we just recently rebranded. Of course, you will sooner or later find contact on me, so you can always reach out via LinkedIn. I actually went through a transformational step a couple weeks ago. I canceled my Twitter and Facebook accounts because I was fed up with all the nonsense that was happening out there, so I'm currently just on LinkedIn. And of course, thank you very much for your time and for listening. And I hope that this presentation wasn't too boring and too business-oriented for you. Maybe it was a little bit, but you will politely say it wasn't. Thank you.
Thanks a lot. So we have questions, and we actually have time to answer them. Number 1. How secure is ID verification from a photo? Can you reliably detect fake IDs, or is it more a security theater?
Yep, this kind of depends on the vendor, really. There are some vendors who do a pretty good job in identifying tampered with document. It is actually good in certain sense because you can capture different attributes of photo capture, like how your camera is moving, and you can do actually this liveness check. So it is, I would say, quite good, but you for example, from compliance perspective, your document doesn't constitute authentication factor. It is not really a possession factor because you are giving your IDs at different places, so it is not really about strongly identifying you. It is about filling in data quickly. It is about having some reference picture. It is about providing some obstacle to the fraudster because they just need to get something else. So I would say, if I should rank it on a scale 1 to 10, I would give it 6. It's good, but you shouldn't rely on it. The facial authentication is more important in this entire flow.
Thank you. Does Wultra provide warranty if bug in your software leads to loss of money of banks or of their customers?
Awesome question. I think there is some of our customers who currently finishes contracts with us because this is the most frequent question we are getting, right? So the way I learned to answer it is that we are not a bank. We cannot really, fully cover a cyber damage for the bank. If I wanted to fully cover cyber damage for a bank, I would found a bank, right? Because I would be ready for the risk, but we are still a software company. So typically we have some liability coverage for our customer, which is limited. And on a theoretical level, it cannot compensate for this worst case scenario that the bank loses all the money due to error in our software. But we do provide some coverage. And we try to also just back to startup building, really, because we were a company of 5 people and we had to go through ISO 27001, right? That's not what you typically spend your money on in a five-member startup. We have liability insurance by Generali, which costs us fortune every year. Just if something happens, we can cover it to a higher extent in, let's say, tens of millions of Czech crown. And we also went through intensive pen testing. We actually pay for third-party pen testers on a product level to make sure that everything is fully protected. But pen testers do certain types of tests. We are also certified by ANSSI, which is French National Cybersecurity Agency. Our authentication technologies are certified, and this was a 3-year process where people who really understand cryptography to a level which was quite uncomfortable to me because I don't like my work being questioned, right? Asked a lot of uncomfortable questions because sometimes small thing in cryptography can lead to catastrophic consequences. Value that is supposed to be used only once is accidentally generated twice, and it blows everything to shit. Sorry. Yeah.
Thanks. How hard is it to detect if a phone is rooted?
Yeah, it's an ongoing race. Every now and then we are ahead of fraudsters, and then typically Magisk make some improvements, and they cloak everything. And so we do small improvements, and we are fighting back and forth with the fraudsters, essentially looking at what they did and improving the technique. I would say that we are still able to keep up. But again, on compromised device, if you have any sign of compromised device, you should probably terminate the application, which is another discussion with our customers because they don't want it. They want to make it secure, but run everywhere. That's not really an option.
Is Wultra usable with multi-platform? Do you plan SDK for Flutter or another multi-platform?
So we currently have React Native wrapper because React Native is the most frequently used multi-platform framework we can see. If we look at it, for example, Honest Bank is one of the examples, or many customers go for React Native. I would say Flutter is currently emerging, so we are looking into it, but we don't have the support yet.
Thanks. Which attacks do fraudsters use most frequently on iOS? Have you seen any 0 days targeting your products?
On iOS, so funny thing is that fraudsters actually use iOS for most of the fraud because it is just worth it. If you make €10,000 per attack on every second attempt, you can actually buy a new iPhone on every attack. You still make quite a good return on the investment. So we can see, and they do it because iOS is actually more difficult to fingerprint and to identify than Android. So that's a bit of a surprise fact. On iOS, I would say this is mostly about fraudsters convincing the user to do something they shouldn't do. For example, they are calling them with a really good idea for investment. They ask them about client number. Of course, they provide it. Then, of course, for security, you need to verify through 3-way identification with your bank. So you will receive a push notification. And they essentially convince the person to approve the payment, approve the login, approve the payment, and approve everything. And you might say, well, that's the user's fault. But as I said in the beginning, this is not something that you can say easily now in banking. So what we have recently implemented is something we call proximity check. We are essentially trying to make sure that if something is happening in web banking and should be happening in web banking, we are sure that the user with smartphone is somehow close to it. And we do it through a combination of a QR code displayed on a screen in random moments, which essentially from the attack surface cuts everybody who is currently running in a tram, with smartphone. They are not able to scan the QR code. And we do it through IP address correlation, which is also quite useful sometimes. So this is something targeting iOS users. There was one more item to the question that you can ask me later. I forget it. I'm sorry. I was talking too much about this one item.
Well, it's great that we have so many questions, actually. Next question. Can the custom Android iOS dangerous? Can it behave as non-rooted but still be dangerous for our apps?
As non-rooted. Yes, that's actually quite an interesting finding. We are running this service called Malwarelytics, and we have a couple of million devices there. And when we started it, we expected to see some problem on Android here and there. And it turns out that malware on Android is actually quite a common thing. It's happening on a daily basis. We see it very often. Various problems on Android are actually quite visible. So I would say it's about Android is more open, but then you give it to hands of normal people, and what the developer can appreciate, normal people can easily misconfigure, right? So back to this question, we actually saw some malware being shipped with devices from factory. That's quite interesting. You don't need to have rooted device if you have application with root privileges running on the device. So.
And the last question that appeared on Slido: how do you follow the last steps from Google to improve security on Android devices? Because it looks like Apple is unbeatable device.
I wouldn't say Apple is unbeatable. I would say that if you look at security issues, both of the operating systems are built on some common platform like Linux or Mac OS. And on this level, there are vulnerabilities that are common to both operating systems. So Apple also has vulnerabilities in Mac OS, right? You can see security updates on almost quarterly basis. And what is problematic from our perspective in Android is that Google has many features that can be abused when used as designed, like accessibility features, ability to read SMS messages, and so on and so on. And one more issue that we actually see, which is bugging me personally quite a lot with Google, is that they introduce new security features, but they do it to the result of it is that we, as security researchers, so to speak, are unable to do certain things why attackers really do not care. So there is the new permission query all packages, for example, that you need to apply for. We need to fill a lot of forms. We need to submit it. Our customers get applications pulled out of Google Play because they do not have proper disclosure of this, ability to query all packages. We do it to identify mobile malware, but fraudsters who do mobile malware do not care, really. So they just publish it on Google Play, and we are just harmless. So Google probably improved something. I'm not sure what. I just don't get it. In iOS 10, Google actually catastrophically broke Strongbox. We had, we improved our storage in iOS 9. We were super happy. We decided to store everything in Strongbox. In iOS 10, it randomly lost data, it got randomly corrupted. So we were thinking, are we stupid? It's a Google software, it cannot happen like this. So we were just searching GitHub if somebody else has this problem, and we found SDK by SourceForge. And it was actually quite funny because they tried to introduce Strongbox, then they commented it out because something doesn't work, we maybe misunderstood something. Then they tried to implement it again with the defensive techniques with try-catch and all this stuff. Commented it out again, and they added a comment, advised by Google that this is not the right use case for us, So Google just breaks secure storage to complete a random state that one time out of 100 items on Pixel devices by Google. By the way, you just randomly lose data. I love Google and Android. I mean, a lot of we wouldn't have anything to do unless there was Google and Android, quite frankly.
The last question, which is more of a comment: social engineering is still the most effective attack, convincing users to do stuff. Otherwise, without a physical access to the device, it's very hard to do.
Yeah, we had some really interesting social attacks. Like just recently in the Czech Republic, I have to give fraudsters 10 out of 10 for creativity. They actually used research project for something called NFC Gate, which is essentially a relay attack with NFC. So you can read NFC on one device and forward data over data channel to another device. And they did it with ATMs and credit cards. So they convinced the victim that there is some problem with their payment card, they should block it. And the way they do it, they download application by the bank, they put the NFC card to the device and enter the PIN code to the card to block it. And fraudster was standing next to the ATM, withdrew, 160,000 Czech crowns, which is how much? 6,000 euros. And left. Amazing. Social engineering in its finest with a twist. But of course, the most common fraud is through investment scam. Somebody tries to help you with investment. They will install any desk for you, just to provide support, and then they just steal your money, including the money you don't have, but you have pre-approved loans. So I'm sorry that I don't have appropriate face to these very sad moments, but I'm already suffering from this mortician syndrome. I saw so many dead bodies that another one bent halfway doesn't just, it's interesting. I just find it interesting.
So that's it with the questions. Thank you so much. You seem to be worried that this talk might seem boring to people, but obviously there's a lot more to talk about. So please stop by the speakers table just outside the room. Yeah. And I urge you to go and ask more questions. Petr Dvořák.
Thank you.